Hey everybody, in this video I'm going to show you how to do a parasitic drain test and find the parasitic draw on your vehicle that's killing it overnight or maybe even in a couple hours. You will need a multimeter to do this job. This is a Fluke meter. You don't have to have a Fluke meter to do this job. It just needs to have a milliamp setting on it. I will put one in the description of the video, one that'll work. Like I said, this one's a little expensive. I'll put a less expensive version in the description of it. I also have some special tools up here that I'll make a supplemental video. That way we can get straight to the draw part of this video. But if you want more information, look in the comments section at the pinned video. Like I said, I will make a video explaining the special tools and how they can help you in case you do this job more than just once. This will give you a little bit more of an explanation. So like I said, this is a Fluke meter. You want to make sure that it has a milliamp setting. We are going to use that. This is a set of leads. I actually made this lead right here. It has a 7.5 amp fuse in it. The reason I made that is so it doesn't blow the fuse in the meter itself. And that's why I'm actually showing you the meter before we get started on this job. These meters do have a fuse in them. If you look here in the amp section, it says 10 amp max. That's so that we don't blow the fuse or mess the meter up while we're doing this parasitic drain test. Before we start doing anything with the battery, what we want to do is we want to open the doors and the lift gate, if there's a lift gate on the vehicle, all of the doors, and you want to go ahead and flip the striker. The reason for this is there's fuse boxes on the inside of the vehicle. Sometimes you'll need to get to those fuse boxes in order to find the drain. You don't want to open the door during the test because what that'll do is it'll wake up the modules and it could blow the fuses in your multimeter. So what you want to do, open all the doors and flip the latch down, and that'll make it think that the door is closed while the vehicle is open. That way you can gain access to anything on the inside of the vehicle. When you're done with the job, you want to put your screwdriver back in it, open the door, and flip the latch back. That'll get it back so that the door will close just fine. So let's go ahead and flip all our latches. One thing I forgot to mention, sometimes your hood latch could also have a wiring harness or something that tells you that the hood is open. You may need to flip that latch as well. So what we need to do is we need to go ahead and disconnect our negative battery cable. Okay, so what we want to do is we want to go ahead and put our meter in the milliamps or the amp section. I always recommend going to the 10 amp max on the amp side first. And what we're going to use is we're going to use the milliamp amp DC voltage setting on our meter. So we're going to go ahead and turn it on. And we're going to go ahead and install our meter in between the negative cable and the battery. And what we're going to do is we're going to let that sit there for 3 or 4 minutes, and then we're going to see what our drain is. We want to see less than 25 milliamps of drain. If it's at 30, that'll be fine, but 25 and less is perfect. Sometimes you'll get a Cadillac or something that has a lot of modules that'll be above 25, 30. You see it's jumping all over the place. So I do have a little bit of a drain, but I'm going to come back in a few minutes and we're going to see what the drain is. Okay, so it's been about 15 minutes and my voltage is jumping up all around still. So the reason I got the fuse box uncovered is that's what we're going to do. We're going to go to our fuses and individually we're going to start pulling them one at a time and watching our voltage. Now, normally you'd start at the closest fuse over here. I'm just going to start here so you can kind of see what's going to happen. No change. No change. Sometimes you'll pull one, and when you put it back in, the voltage will spike way high because the module comes back awake. No change. No change. And our voltage jump, and now look, our voltage is dropping down, dropping down, dropping down. We're below 25, which is perfect. And it's going to keep going. It's going to go to about between 5 and 8. That's where this vehicle sits. Less than 25 is perfect. You won't ever see a problem if it's less than 25. Now, now that you've pulled the fuse and you see that the voltage is lower, you're going to look and see what that fuse controls. And this fuse right here controls the cigarette lighter. Okay? So what we would want to do is we'd go to our cigarette lighter and see if there's anything plugged in, any kind of accessory or anything like that. I'm going to go ahead and plug this back in. And if you see, once you plug it in, the voltage jumped back high. That's because there's a draw in the cigarette lighter system. So we go to our cigarette lighter and we disconnect it. Or we'd find out if, for instance, if it was the radio, if I pulled the radio fuse and it dropped down, we disconnect our radio and see if the draw goes away. Or if it was a light on the inside of the vehicle, an interior light, we disconnect our interior lights until we found out which light was controlling it, or which light was causing the draw. So we pulled the 20 amp fuse for the cigarette lighter. Let's go find out where our draw is. All right, so if we look in our cigarette lighter, we'll see right here I have a USB plug. Now I know this USB plug had a problem. I actually changed it for a customer. I found their drain. The drain was the USB plug. Anything that's plugged in here can cause a drain. This one's just shorted out on the inside, causing a big drain. A 300 milliamp or higher drain like that will cause the battery to die in a couple hours or overnight, depending on how good the battery is. So what we're going to do is we're going to go ahead and disconnect it, or take it out, I should say. All right, we're going to watch our draw. We're down to 0.007 milliamps draw, or amps draw, I should say, which is about 6 milliamps of draw right now, which is perfect draw for this vehicle. If you have less than 25 milliamps draw, you won't see a problem if you drive the vehicle every day, but the lower the draw you can get, the better. Anything can cause a draw. I've seen headlights that were busted cause draws, even when it was turned off. Anything that has power going to it, if the power is flowing through it, it's drawing your battery down. Where at 0.005 amps draw, which is 5 milliamps draw, this is perfect draw for this vehicle. Once we've removed the draw, we're going to go ahead and disconnect our meter. Go ahead and reconnect our battery. And you're done. I hope this video was helpful. If it was, go ahead and give it a thumbs up. And as always, if you haven't already, please go ahead and subscribe. Thanks again for watching. Now, I'm not the kind of guy that's going to ask you to like my video or subscribe to my channel. I'm the kind of guy that's going to beg you to do it. Click one of these other videos. Subscribe to my channel. It's on one of these sides. Do them both. Do them all.